Write the area of the rectangle at right as a sum and as a product. So first I'll write it as a sum. So that's going to be 2x squared. And I've got negative 3x and negative 8x, so that's minus 11x's minus or plus 4xy's minus 6y's plus 12. And then the product. So let's see, to find the product, I'm going to find common factors. So a common factor of negative 3x and 2x squared is x. A common factor of negative 3, negative 6, and 12 is negative 3. Negative 3 times 2 will give us negative 6, and that must be a y, because both of these have y's. Negative 3 times negative 4 would give us 12. And then a common factor here is 2 and x, so 2x. So 2x times x is 2x squared, 2x times 2y is 4xy, 2x times negative 4 is negative 8x, so we're good. So the product would be 2x minus 3 times x plus 2y minus 4. Multiply the expressions below using a generic rectangle. Okay, so we've got 4x minus 1 and then 3x plus 5. So 4x times 3x is 12x squared, negative 3x. This would be 20x, negative 5. So we say that this equals 12x squared plus 17x minus 5. Here we've got 2x minus 7 squared, which is just 2x minus 7 times 2x minus 7. So that's 4x squared, negative 14x, and same thing here. And then negative 7 times negative 7 is 49. So this equals 4x squared minus 28x plus 49. Factor the following expressions using the box and diamond method. So first we'll make a box. I can fill out the x squared, so 2x squared and negative 12. And I know that my x's have to add up to 5x, and they have to multiply to negative 24x squared. So I know things that multiply to 24 are 1 and 24, 2 and 12. Those don't add or subtract to 5. 3 and 8. Oh, those subtract to make 5. I know one of them has to be negative because this is negative. So the 5 is greater, so the 8x must be positive and negative 3x. Okay, now I can find common factors. A common factor of 2x squared and 8x is 2x. So that means this must just be x, which means that this must be negative 3. And over here we must have 4. So when we factor this, it equals 2x minus 3 times x plus 4. This one, I've got x squared and negative 12. I know that I need two numbers that multiply to make negative 12x squared and add to make x. 3 and 4 multiply to 12 and add to 1. So it must be positive 4 and negative 3. So we've got x and x. Let's see, negative 3 here, 4 there. So this equals x minus 3 times x plus 4. here we'll make our box. We got 3x squared and negative 10. So I know I need numbers that multiply to make negative 30x squared and add to make negative 13x. So first I'm going to list numbers that make 30. 1 times 30 doesn't add up to 13. 2 times 15, oh, that subtracts to make 13. Because 13 is negative, the 15 must be negative. Negative 15x and 2x. The common factor here between 3 and 15 is 3x. So this must just be x, that must be 2, and negative 5. 2 times negative 5 is negative 10, so we're good. So this factors to 3x plus 2 times x minus 5. And then the last one, 8x squared, negative 3. We need numbers that add to make negative 23x and multiply to make 24x squared negative. I know that since these are just one apart, it's going to be 24 and 1. So negative 24x and 1x. I know that a common factor here is 8x, and then that'll just be x, that's 1, and then negative 3. So this factors to 8x plus 1 times x minus 3. Use what you know about multiplying binomials with a generic rectangle or an area model to change the quadratic equation into standard form. So I can multiply out these two binomials, x minus 4 and x plus 2. X squared, negative 4x, 2x, and negative 8. So I can rewrite this as f of x equals x squared, negative 4 and 2 makes negative 2x minus 8. Use both forms of the equation to graph the x and y intercepts of the parabola. So this equation in factor form tells me the x-intercepts. So it tells me that the x-intercepts are going to be 2 and 4. Because if we use the zero product property, we solve this equation, x minus 4 equals 0, x plus 2 equals 0. So sorry, this is going to be negative 2 and positive 4. Then we can use the standard form to tell us the y-intercept is going to be negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So to find the vertex, so first we have to find the line of symmetry. In the middle of the x-intercepts. So let's see, 1, 2, 3, 4, 5, 6. So halfway to 6 is 3. 1, 2, 3. It's right here. So the line of symmetry is x equals 1. Plug in x equals 1 to the equation to find the y value. Of the vertex. So we could plug in x equals 1. I'll plug it in here. So we get that y equals 1 minus 4 times 1 plus 2, which is negative 3 times 3, which is negative 9. So the vertex is at 1 comma negative 9. And then we can graph that parabola. Okay, graph the following lines and label each line and write its equation. So line A has a slope of 4 and a y-intercept at 0, -3. Slope of 4, 1, 2, 3, 4, and to the right 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So here's the line. This is line A. Its equation is y equals 4x minus 3. The slope is 4 and the y-intercept is -3. Line B has an x-intercept at 2, 0. So that's right here. And a slope of -2. So down 2 to the right 1. So to find the y-intercept, I'm going to keep going. Up 2 to the left 1, up 2 to the left 1. So it's right there. So the y-intercept is 1, 2, 3, 4. So the equation is y equals -2x plus 4. And this is line B. Line C is horizontal and goes through the point 1, 6. 1, 1, 2, 3, 4, 5, 6. Horizontal means like that. So horizontal lines all have the same y value. Here the y value is always equal to 6. So the equation of the line is just y equals 6. This is line C. Line D goes to the points -4, -3. 1, 2, 3, 4. 1, 2, 3. And +4. 1, 2, 3, 4. 1, 2, 3. So it goes through these points. So to find its slope, we're going to have to draw a slope triangle. So we went over 1, 2, 3, 4, 5, 6, 7, 8, and we went up 1, 2, 3, 4, 5, 6. So the slope is 6 over 8, which is 3 over 4. So I'm going to see if I can find the y-intercept that way. So I go up 3, 1, 2, 3, and over 1, 2, 3, 4, oh. So the y-intercept is at 0, 0. So the equation of the line is just 3/4 x. And we could write +0, but we don't have to.